You mentioned last meeting, miss, nga napakay i-discuss. Then, group 1 na dayon.
Yes, so I'm just checking. I'm just
Yes,
checking if
Miss
you
Lee.
already, okay. So Kapalaran, Cavite, Inot, Lisao, and Santos are in charge for the earthworks and excavation. Okay, so for your class reporting, there will be two grades. One is group grading, and the other grade is the individual grade. Okay, so your group grade will be the content. Okay, so you will be graded based on the content, based on the delivery, okay, based on the teamwork. Okay, so for your individual also is the same, the delivery and the content. So I'm expecting everyone have a part on your presentation. Okay, so I will continue first, maybe around 30 minutes, and then after that, group one will start. Okay, so last time, we discussed about the how to take the approximate estimate based on the data of the previous project. Okay, another is based on the index of the past, the cost of the past project by location adjustment, by also the time adjustment. Okay, so what else we discussed? We also discussed the um, construction cost of labor. Okay, so we have two types. We have ownership cost and we have also operating cost. Okay, so for the ownership cost, um, okay, I'll share my presentation first. Okay, so let's just have a recap first. Okay, so for the recap, okay, so we use this equation, okay, for the unit cost. Okay, and then this is our example. Then next we use this equation for the time adjustment problem. Okay, so this equation, forecast cost equals previous cost times 1 plus the interest raised to the power raised to the number of years. Okay, so for the location adjustment, okay, so we use this formula, the forecast cost, okay, equals the previous cost times the location index of the proposed divided by the index of the previous project. Okay, so next, okay, we discuss about the importance of labor and the cost of labor, okay? And then here we discuss how to get the labor cost, okay? After that, we take the production rate or the unit cost. And then the next is the cost of the construction equipment. Okay, so here we have two equipment costs, the ownership and the operating cost. Okay, so for the ownership cost, two formulas, okay? The capital recovery equation. Okay, so if there's a future salvage value, then we need to add the sinking fund equation. Okay, and then here we also have a formula how to get the lubricating oil consumption. We also have how to get the fuel consumption. And then, okay, so we try a problem on the equipment cost. Okay, and then if there is salvage value involved, okay, so okay, and then after this we discuss about handling and transporting material. Okay, so how to calculate the cost for delivering material from the storage yard to the construction site. Okay, so last time, so muna atong example last time, katong dump truck that can take 12 cubic yard to deliver a 175 ton of sand. So may atong last example. So sa first example, ang atong manpower is 2 laborer and a driver. So based on this, nakuha nato ang iyang unit cost na 25.33 per cubic yard sa 2 laborer and 1 driver. So ni try tag another way. Okay, ni gamit ta og tractor loader. Okay? Sa pagloading sa 175 ton of sand. So nakuha nato nga ang iyahang unit cost is 10.44 cubic yard. Okay? So here, okay, here sa atong summary, so sa example 1, so muna atong manpower, duha ka laborer o isa ka driver. So ang unit cost per cubic yard is 25. Pag mo gamit ta og tractor loader, so mapaspas ang atoang trabaho. So mas makabarato ta. Okay, nakabarato ta og $15. So tag 10.44 per cubic yard ra atong nagasto. Karon, what if mo try ta og kuan, since ang nag-deliver sa sand kay usa ra ka dump truck. Since paspas man kay atong loading, no, kay ni gamit man tag tractor loader. So suwayan nato nga upat ka buok atong gamiton nga mo deliver sa site, mas makabarato ba ta? Okay? So let's check for this example. Okay, so example 3. Okay? So sa example 2, last time, ang travel time is greater than the load time. Okay, kay ang travel time kay kuan ra 0.48 mo ni ang travel time. O niya, ang iyang load time gamay ra kaayo, so kadyot ra kaayo nagload kay paspas man ang loader. Pero ang travel time perting taasa kay isa ra man siya ka dump truck. So karon, what if atong suwayan nga mopuno ta og laing dump truck para makasave ta og cost kay kuan, but pasabot, for example 20 minutes ra ang load time pero ang travel time is 40 minutes, no? So nakabalik ng 40 minutes na wala pa ni balik ang dump truck. Okay, so here para atong ma-check kung pila ka dump truck atong need. Okay, so ang atong cycle time na 0.584. So okay, na diri atong cycle time ha. Okay. Sa problem 2, ang atong cycle time, so sa pag-deliver sa material, sa pag-load, sa pag-travel, sa pag-unload, sa pag-return sa dump truck, ang total nga time na gamit niya is 0.584 hour per trip. Okay? So karon, sa mo na ang ato ang cycle time. So karon sa atong problem 3, atong suwayan na, okay, so cycle time, overload time, so may atong cycle time. Unya ang pag-load kay 0.126 ra hour. So but pasabot, kinahanglan ta og 4 trucks. Okay? Para mo balance ang ato ang load time ug ang atong travel time. Okay. So here, so considering 4 trucks, so the production rate, okay, pag 1 truck, di ba kay ang usa ka dump truck kay 12 cubic yard raman ang iyang makarry. So divide na to og 0.584 hour per trip. So ang makaya nga kuan is muna siya, muna ang kuan katong iyang makaya ra nga load 20.5 cubic yard per hour. Mura ni ang iyahang makaya. So what if upat ka truck atong gamiton? So 20.5 cubic yard per hour times 4 truck. So but pasabot in 1 hour naka-carry na ang dump truck ang upat ka drum truck og 82 cubic yard sa sand. Okay. And then, we have a total of 130 cubic yard divided by 82. So, but pasabot sa 1.6 hour, ang 132 nga kuan nga sand or the 175 ton on sand, pwede ra mahatod sa dump truck og usa ka oras og 0.6. So dali ra kaayo na human. So if you remember sa atong previous na example sa number 1, na nigamit ta og 2 laborers ug 1 driver, upat ka oras nilang tinarbaho. Okay? So kung mogamit ta og kanang upat ka trucks, nya mogamit pa jud tag loader, usa ka oras ra kapin nila nahuman. Okay? So here, so ato i-calculate ang cost. Okay, so remember sa previous project, ang loader 50 per hour. So since mahuman ra nila og 1.6, so 80 ang cost sa loader tractor. Okay? How about sa operator? So sa previous project na mention nga ang cost sa operator kay 21 per hour. So 1.6 times 21 per hour, so 33 ang iyang labor. Okay, so how about sa truck? So 1.6 times 4 trucks, unya tag 25 man pud to ang truck. Okay? So 160 ang cost. Okay, plus the driver. Okay, so ang driver kay iyang labor is 18 per hour, unya upat ka driver kay upat ka truck times 1.6, so 115. Okay, so pag imo nang i-total tanan, 388.8 ang cost. Then na-mention po sa previous problem nga ang loader 400 ang bayad sa rental. Okay? So the total cost sa upat ka truck is 788.8. Okay? So here, so the cost per cubic yard is 788 divided by the total quantity sa sand is 6.7 cubic per yard. So muna ang atong production rate. So if you notice na the more resources, okay, mas lesser. So depende siya sa evaluation. Okay? So okay, never mind na ng 5 trucks. Okay, so here, so atong ma-compare nga kung magpuno tag dump truck, 0.5 ang cycle time, 82 ang production rate, kay nagdungan man ang upat, so mas makabarato ta. So $6 ra siya per cubic yard. Kung i-compare nimo diri nga 25, okay? So say plate kung giyon kanina class 3 hours day, dili day 4 hours. So 3 hours nila nakuan ang driver ug ang laborer. So kung imo rang i-compare kung magamit kag tractor na 0.5 ra ang cycle time, unya ang production rate kay mo taas pa jud since ni gamit ta og upat ka dump truck. So here imong na na compare na mas wiser na mo gamit kag loader compared sa manual labor, and then mas wiser pud nga mo dagdag kag dump truck since paspas imong loader kaysa usa ra ka dump truck, kay magpaabot imong tractor nya wa pa nibalik imong dump truck, so na idle na imong tractor og pila ka oras. So unang naalkansi ka sa cost. So imagine kung nigamit ka naka less ka og $4. Diri naka less ka og $15. So that is how you estimate nga makales inyong company. Para mas makales mo, okay, so the greater your profit. Okay, so ingon ana siya class. Okay, so muna siya example on how to estimate the cost of handling and transporting material. Okay, so kanina kanina, okay, atong i-try nga what if 5 trucks atong gamiton. Okay, kung 5 trucks atong gamiton, so 130 divided by 95, ang production rate ani kay nahimo na siyang nahimo siyang pag 5 trucks atong gamiton, ang production rate is 95 cubic yard per hour, kay kuan man siya gi times 5. Okay? So here ang time nato kay nahimong basin na libog mo asagi ka ng 95. So ato ra nang gi-multiply ang 20.5 og 5 trucks. Okay? So muna na ang atong production rate. Okay, so kung time ang 130 cubic yard divided by 95. So matrabaho ra nila 1.4. Pero kung imo i-compare 1.4 times 50, 70 ang cost. 1.4 hours times 21, mao na ang cost sa operator, 29. Okay, so na ay trucks nga 1.4 times 5, 25 ang kuan imong cost sa truck. So 175 ang cost. Okay, how about the driver? So 1.4 times 5 drivers, koy tag 18 ang driver. So 126. So pag imo nang i-total, 400 imong cost. Unya plus pa jud sa bayad sa loader pag transport 400. So ang total cost nimo is at 800.4. Okay, so ang 800.4 divided by the total density of sand, so 6.16. So mas nakamahal kagamay compared sa 4. So dili na ideal nga 5 trucks. Okay, so ang ideal lang is only 4 trucks. So muna ang pinaka-less.
Excuse me, Miss.
Yes?
Anong sa production rate mo ba? Consider using 5 trucks. 20.5 times 5. Kay, dili ba na 102.5 ma'am?
Wait ha. Dili day 95, sorry. Okay. Okay, for a while ako sang i-check ha.
Now, to verify if this point is maximum or minimum, we need determine second siya.
Sayop day siya. Pila to? 102.
Find the second ano,
0.5.
find the second derivative. So, kapag ang first derivative, multiply plus the x squared. And as soon as I differentiate, determine the
Okay, ako sang i-check class kung
x squared minus x squared. 6x
class kung naay gustong musud ha, dili ko kakita kung naay mo kuan kanang naay mo magpa-admit. So please inform me kung naay magpa-admit kay naapatay duha ka absent. Dili ko makakita sa Google Meet. Okay, kajut lang class akong i-verify ang 95. Okay na pala yung mosulod. Wala na. Okay, kinsa tong bagong ni sulod, can I have your name for the attendance? Again, sorry, I cannot hear you properly.
Alferez, Mama Jane.
Alferez, okay.
Yes, ma'am. Thank you, ma'am.
Okay, for a while class ha, kung i-verify ang 95 na cycle or so nasayop akong kuan class, nasayop akong computation, it should be 102.5. Okay, so sayop jud ay siya. Okay, so kani siya class ha, 102.5 ni class. Okay, kani ilisa na siya 102.5. Okay. So 130 divided by 102.5. So kani is not 1.2 but 1.27 R. So kani siya class, multiply ni tanan by 1.27. Okay, so atong i-correct ang atong answer. So 1.27 times 50. So na 63.5 ang imong cost sa loader. Okay? And then for the operator, 1.27 times 21. So ang imong cost sa loader sa operator is 26.67. Okay, so 1.27 times 5 trucks, then 25 ang cost. So 158.75. Okay? And then how about for the driver? The driver is 1.27 times 5 times 18. Okay, so this will be 114.3. Okay, so um, so the total will be 63.5 plus 26.67 plus 158.75 plus 114.3 will be 363.22. Okay, so plus the cost of your loader. So plus 400. Okay, so the total is 763.22. Okay, and then divided by the total cubic yard. So our answer will be 5.87. Okay, 5.87 cubic yard per cubic yard. So, but pasabot, mas makalesser paghihapon ta if 5 ka dump trucks ang atong gamiton. Okay? So here, pwede naman siya ma-delete class. Okay, so here, sa kaning mga problem, we can compare kung asa ka mas makales. So, you can compare if manual labor, you can compare if asay mas practical nga mogamit ka og equipment, and mas practical nga usara ba or duha or tulo or upat. So depende. So that is how you need to compare. So as a quantity surveyor in the future, so you need to compare which is more practical for you. Okay, so this is only an example of how to calculate the cost of handling and transporting the material. Okay, so thank you for correcting this one. Okay, so now, so this will be the end of my presentation. Okay, so next group, will start for the earthworks and excavation.
Determine the second equation. Wala, nibalik ko daw.
So, good afternoon, everyone. We are the Group 1, and we are about to discuss a new topic for this afternoon. So, before that, let me introduce to you the class reporters. Next, please. So, here are our class reporters for today. Miss Clara Cavite, yours truly, Jessica Faye Kapalaran, Mr. Joey Inat, Miss Laika Marie Lisaw, and Stanley Mark Santos. So before we start this discussion, let us have a short icebreaker. So the game is Make It Make Sense. You are about to guess what the series of pictures are implied or indicate. So you may send your answers in the chat box, guys. So that is the first item. Active. So we already have answers in the chat box with Mr. Solon, which is earthwork. So let us reveal the answer. So sakto. So earth and the formula of work. Next item. So guess the pictures. What the picture implies. So make it make sense. Wow, dali ka answer. So we have first picture X, we have a cat, minus the T, vat, and then on. So let's reveal the answer next, please. So sakto yung answer guys, excavation. So that will be our topic for today. Next, it's earthwork and excavation. So thank you for participating. So to define earthworks, operations include the excavation, transport, placement, and compaction of fill materials to construct earth structures and is a significant element of almost all civil engineering projects. Meanwhile, excavation is the process of removing soil or rock from a specific area to create a foundation for a new structure. So to make it short, excavation is one of the operations in earthworks. In relation to um, quantity surveying, it is usually a relatively simple operation to determine the quantity of material to be excavated, and it is more difficult to estimate the rate at which earthwork will be handled by excavating equipment. So this is because the rate at which earthwork is handled by excavating equipment depends on several factors. And these several factors are divided into two groups. So we have job factors and management factors. So first is the job factors. So listed below were the job factors that affects your excavating rate. So we have type or classification of soil, extent of water present, weather conditions, freedom of workers and equipment to operate the job, the size of the job, length of hole for disposal, and many more. So the contractor must analyze these each job factors to determine the conditions that can affect construction operations. So for earthwork projects, so the bid documents usually contain a soil report. So that is to identify the type or classification of soil. So this provides geotechnical information about the soil and subsurface conditions. So mo to example for job factor nga ma-affect sa operation. Next, we have management factors. So these factors are under the control of the contractor. So first, we have organizing for the job, then maintaining good morale among workers, selecting and using suitable equipment and construction methods, exercising care in servicing equipment, and establishing good field supervisory personnel and others. So these management factors are controlled by the contractor. So the contractor has a control of his or her operations and can overcome adverse job conditions by good management practices. So for example, kay in your hauling, para ma-maintain nimo ang efficiency and productivity of scrapers or mga trucks. So that must naman ay mga management ay mohang kanang heads will manage your operations if asa ang first nga buhaton and unsa ang mas efficient nga procedure or method. So next, we have the properties of earth. So to estimate the cost of excavating and hauling earth, it is necessary to know the physical properties of earth because the volume changes during construction operations. So based on the figure presented, so for an earthwork operation, the soil is excavated and then from its natural state, and then placed in a hauling unit or transferred in a hauling unit and transported to the disposal area where it is either distributed or compacted. So usually it is compacted. So the earth material can be measured as excavated, hauled, or compacted. So next. So earth or soil that is to be excavated is called cut or bank measure. So usa ni siya sa mga measures in costing sad. If it so The first one is to cut or bank measure. So the variation in unit weight depends on the type of soil and moisture content. So the soil report for a project provides the classification, unit weight, and moisture content of samples from borings that are taken during soil investigation. So in simple terms, mo ni siya ang land pa nga wala nimo hilabti and this is to be excavated pa. So cut or bank measure. Next, we have loose measure. So mo ni siya ang earth that is placed in a hauling unit for transportation to fill the area. So mo ni siya ang na-excavate na nimo and ibutang na nimo sa imong hauling unit like from your area and then gi-excavate using bulldozer, gibalhin nimo sa truck for truck, which is an example of a hauling unit. So after being loosened during excavation and placed in a hauling unit, earth and rock will occupy a larger volume, so with a corresponding reduction in weight per unit of volume. So this increase in volume is described as swell and is expressed as a percentage gain compared with the original volume. So mas mudako ang imong volume from the cut or bank measure kaysa sa loose measure. So next please. So earth that is to be compacted is called fill or compacted measure. So kani siya is smaller ang iyahang volume nga ma-occupy. So after being loosened during excavation and placed in a hauling unit, earth and rock will occupy a larger volume with a When earth is placed in a fill-in area compacted with compaction equipment, so it occupies a smaller volume than its natural state. So compared with the cut or bank measure, this fill or compacted measure kay smaller ni siya ang volume, and this decrease in volume is described as the shrinkage. So it is expressed as a percentage of original volume or bank measure. So in relation sa katong tulo, so distinguishing those three, the bank, the loose, and compacted measure is extremely important para sa mga estimator and the bidding process because the contractor may be paid by any one of the three units of measure, katong bank measure, the loose measure, and compacted measure. So the contract documents define the measure of payment to the contractor of earthwork. So magdepende sa katong tulo kung unsa ang gi-indicate sa inyong bid documents ang bayaran na i-calculate sa estimators. So to calculate those three, we have these following equations. So mo na siyang correlation between the unit weights, the volumes, swell, and shrinkage that can be obtained sa kaning four equations. So it is calculated either by volume or by weight. So by volume, we have a volume of loose soil is equals to 1 plus the percentage of swell over 100 multiplied by the volume of undisturbed soil or katong bank measure. So B is bank measure or undisturbed soil. Equation 2, we have the volume of compacted soil is equivalent to the quantity of 1 minus the percentage of shrinkage over 100 multiplied by the volume of undisturbed soil. And by weight, we have equation 3. The unit weight of soil is equivalent to unit weight of undisturbed soil over quantity of 1 plus the percentage of swell over 100. And lastly, equation 4, which is the unit weight of compacted soil, is equals to the unit weight of undisturbed soil over the quantity of 1 minus the percentage of shrinkage over 100. So, presented are the kanang tables that can help in identifying the material or the swell as well as the bank weight. So the estimator can prepare the estimate in any unit of measure, but the final bid amount must correspond to the unit of measure specified in the contract bid documents. So in table 7.1, so this provides the range of percentage of swell for various soil. So if you are given the swell, you can identify yung sana nga material ang i-excavate. As well as in 7.2, it provides the representative unit weights for various types of earth and rock. So mo na siya ang bank weight, which is expressed in pound per cubic feet. So to give you an example, in calculating or estimating the soil to be excavated, so this is a sample problem. So clay soil, whose bank unit is 105 pound per cubic feet, is excavated and hauled by 22 cubic yard loose measure trucks that have an empty weight of 67,500 pounds. An evaluation of the physical properties of the soil indicates a swell factor of 30%. Based on 4 passes of the compaction equipment, it is anticipated the shrinkage factor will be 15%. For each 22 cubic yard truckload of soil that is hauled, calculate the equivalent bank measure and loose measure volume. Also, what is the total weight of the hauling unit and payload of soil that is hauled on each truck trip. So we must find first the equivalent bank measure and loose measure volume, and then next the total vertical weight of the hauling unit and payload of soil that is hauled on each truck trip. So ako nang gibutang diha ang kanang the equations that are needed, but dili jud na tanan ang magamit, so depende ra sa atong given. Since next, I hope maklaro ra. So we are given, diba, 22 loose volume of soil, and we are to calculate the equivalent bank measure. So it is indicated in letter B. So for that, we can use equation 1, wherein L or loose volume of soil is equals to 1 plus the swell over 100 times the bank measure. So given sa dang bank measure, which is 30, so substituting in the formula, we can get the bank measure or bank volume of 16.9 cubic yards. Next is kuha na to ang iyang equivalent nga compacted. So using the calculated nga bank volume, imo na siya i-substitute sa equation, which is volume of compacted soil is equals to 1 minus iyang shrinkage nga given said, which is 15% over 100 multiplied by 16.9. So ang makuha nga compacted volume is 14.4 cubic yards. So for total weight of a truck and its soil payload, we can use the formula katong by weight. So use ikatong by weight, loose unit weight nga volume, loose soil unit weight is equivalent to the bank undisturbed soil or bank measure in unit weight over 1 plus iyang swell over 100. So given man sad ang ato ang unit weight for bank unit weight, which is 105 pounds per cubic feet, we have, and 30% sa iyang swell factor, so natay 80.8 pounds per cubic yard nga loose weight of soil. So to get the payload, kuha na to ang iyang mass or in pounds. So i-multiply nimo ang unit weight sa iyang volume, which is 80.8 times 22 cubic yards. And since kuha na siya convert from cubic feet to cubic yards. So we have 80.8 times 27 times 22, which is 47,995 pounds. So to get total weight, we have an empty truck nga given nga 67,500 plus ato ang soil payload of 47,995 pound. Makuha na to ang total vertical weight, which is equals to 115,495 pounds. So thus, for each truck trip, the amount of soil that is handled is equivalent to 16.9 cubic yard bank, 22 cubic yard loose, or 14.4 cubic yard compacted, and each truck load weighs 115,495 pounds. Next topic. So, I hope na sabta na to siya. Okay, kung ano man to. About to sa katong substituting formulas na makuha ni mga soil payload and then the truck, total weight truck. So, next we have methods of excavating and hauling earth. So, there are various types sa pag-identify sa methods nga imong gamiton. But, usually, or atong naibaw anjud is that by hand and by equipment. So, in by hand or manual, so these are for smaller jobs nga makaya ra sa hand digging and shoveling. Meanwhile, for equipments, nga mag-use of equipments, this is for bigger jobs. So, mag-use ka of equipments like backhoes, front shovels, drag lines, clamshells, and so on. So some materials such as rock is so hard that it is necessary to place explosives and drill holes to loosen it prior to excavating. So next. So these are the example sa kuan using the equipment wherein mag-select ka of excavating equipment depending on the soil type and job site conditions. So we have a front shovel and a drag line. So sa front shovel, we have a loosened excavation pit, and then for drag line, kay extensive water present. So next.
Now, let's move on to excavating by hand. So in excavation, there are numerous factors to be considered in a particular job. First is the type and the quantity of material to be excavated. Second, the depth of excavation. Third, the amount of groundwater in the construction area. Fourth, the required hole distance. And lastly, the space available for operation of the equipment. So generally, it is desirable to use excavating equipment instead of excavation by laborers. However, sa uban na job sites, dili enough ang space para sa isa ka equipment na mo-operate. That's why we have this method of excavation. We have excavating by hand. So in this method, naatay rates, next slide. So in this method, naatay rates of handling earth by hand. So in excavating sandy loam, so sa 1 to 2 na cubic yard, naatay rate na 0.5 to 1 hour of operation. Second, shoveling loose earth into a truck, so 1/2 to 1 cubic yard is 1 to 2 hours. Loosening earth with a pick, 1/4 to 1/2 cubic yard is 2 to 4 hours. Shoveling from trenches or pitches, we have 1/2 to 1 cubic yard, then 1 to 2 hours yung operation. Then sa backfilling earth into trenches, we have 1 and 1/2 to 2 and 1/2 cubic yard, 0.4 to 0.7 hours. Then lastly, sa spreading loose earth, sa every 4 to 7 cubic yard kinatay operation na 0.15 to 0.25 hours. So next slide. So here is an example. Example, excavation for a trench in a confined area of a refinery requires excavation by laborers. So estimate the cost of excavating and backfilling the trench, which is 3 feet wide, 4 feet deep, and 15 feet long in sandy loam. So given the dimension, first thing we're gonna do is to determine the quantity of work. So with the dimension 3 feet by 4 feet by 15 feet, ato ni siyang i-multiply and then i-convert into cubic yard para magamit nato sa tong production rate later on. So in 1 cubic yard natay 27 cubic foot. So 3 times 4 times 15 divided by 27 is 6.7 cubic yard. Next is unsa may production nato in excavating for a trench. So atong production ani is to loosen the earth. So based sa given table ganiha, sa pag-loosen daw sa earth na atay production rate na 2 hour per cubic yard. So i-multiply nato siya sa atong quantity of work which is 6.7 cubic yard, then we'll have 13.4 hours of production. So shoveling earth from trench, we have 6.7 cubic yard times 1 hour per cubic yard of operation. We have 6.7 hours. Then shoveling earth back from trench, we have 0.5 hours per cubic yard. So multiply it by 6.7 cubic yard, we have 3.4 hours. Then sa backfilling trench, we also have 0.5 hour per cubic yard. Then multiply to 6.7, we have 3.4 hours. So ato siya i-add tanan, then atong total labor hours will be 26.9 hours. So next, sa pag-estimate sa tong cost, so assuming ang kani kay naa siya ang rate per labor is 15.56 per hour. So total labor hours times the rate sa labor which is 15.56. So the total cost will be $418.56. So to compute for the cost per cubic yard, we have the total cost divided by the quantity of work we have. Then we'll have 62.47 per cubic yard. And then sa cost per linear foot, so naman diri sa atong given no nga 15 feet long daw. So 418.56 divided by 15 foot is equal to 27.90 per foot. So that will be our final answer. So next method, we have excavating with trenching machines. So kanino method, if dako na jud ang kailangan job, then excavating with trenching machines is more economical. So the cost of this method in excavating is considerably less than the cost by hand. So trenching machines can be purchased or rented. And actually, there are several types available, but a trenching machine with a dozer blade attached to the front, as you can see on the screen. So this type of machine is frequently used. So next slide. We have here so we have here a formula of the digging speed of the trencher. So S is equals the digging speed in feet per minute is equal to C, the soil factor, times the horsepower of the trencher, all over the depth of the trencher in inches times W, the width of the trench in inches. So we also have a table here, table 7.4, representative sizes of trenches for small trenching machine. And sa table 7.5, we also have values of soil factor C for small trenching machine. So this will be our basis sa itong pag-estimate sa itong cost later on. So next slide. Let's have here an example. Example, estimate the total cost and cost per linear foot for excavating 16,850 feet of trench in hard clay for an underground cable. The trench will be 9 inches wide and the average depth will be 66 inches. So a rubber tire trenching machine with 65 horsepower will be used. The cable will be installed in open terrain, so there will be no major obstructions to retard the progress of the machine. So assume a 45-minute hour to account for normally expected delays. So una natong buhaton is ato to i-apply ang formula. So the digging speed is S is equals to C times HP over D times W, right? So na-mention siya sa problem na hard clay guno ato ang type of soil. So based sa atong table ganina, hard clay is 40 daw iyahang soil factor. So kanang ato siyang i-substitute 40 times the 65 horsepower all over 69 daw ang depth and then 9 inches ang iyahang wheel. So we'll have 4.4 feet per minute. Now next is we're gonna solve for the time required for trenching. So sa productive time, yan na siya nga ato ang scope guno is 16,850 feet. So we're gonna divide 16,850 feet sa ato ang digging speed of 4.4 feet per minute. Then to convert that into hours, ato sad siya i-divide og 60 minutes over 1 hour. So we'll have 63.8 hours. Now, ni-mention siya, assume a 45-minute hour guno for normally expected delays. So, ato na siya i-multiply 63.8 hours times 60 minutes over 45 minutes. So, naatay 85 hours. So, ato siya i-round off kay full 8-hour day. Diba 8 hours man dyan ato ang work every day. So, ato siyang i-round off. So, mahimo siya og 88 hours. Now, to estimate the cost, sa trenching machine guno naa siya 32.50 per hour. So i-multiply nato siya og 88. 88 times 32.50, we have 2,860. So sa machine operator, so 21.67 per hour guno iyahang rate. So times 88 naatay 1,906.96. Sa utility truck na atay 7.50 per hour times 88, we have 660 pesos. I joke, dollars. Then sa laborer, 15.56 per hour ang rate times 88 is equals to 1,369.28. Then sa foreman, kay 25 per hour times 88, we have 2,200. Then, moving equipment to and from job, so naa sila gibgahin nga $500. So, to add sa tanan ani nga cost, naatay total cost na 9,496.24. Then, we were also asked to estimate the cost per linear foot. So, the total cost divided by 16,850 foot is equals to 0.56 per foot. So that will be our final answer. Okay, so we also have here different types of trenching machine. We have well type trenching machine and the ladder type trenching machine. Wala. Naman siguro na yung picture. Wala nakita. Okay, sige lang. So, sa wheel type trenching machine, previous slide sa. So, wheel type trenching machine, this is frequently used for water mains and gas and oil pipelines. So, this type of machine can be used to excavate trenches from 16 to 30 inches wide and depths up to 6 feet. Then, sa ladder type trenching machine, this is mainly used for sewer pipes and other utilities. So this type of machine can excavate trenches from 16 to 36 inches wide and depths up to 12 feet. So next slide. Wala nakita ang pizza. Sige. So actually we have a table provided sa atong kuan pero marag naay something wrong sa atong PPT. So let's move on na lang sa example. So estimate the total cost and cost per linear foot for excavating a trench 30 inches wide with an average depth of 7 The trench is 2,940 feet long in common earth. A ladder type trenching machine will be used, and there will be no obstructions to retard the progress of the machine. So assume an efficiency of 45 minutes per hour. So table 7.7 indicates a digging speed between 30 and 60 feet per hour. Assume an average speed of 40 feet per hour. So nana siya ka ng digging speed no, so dili na ta mag-make use atong formula. So atong buhaton is to compute for the time to complete the job. So productive time, so 2,940 feet guno atong project. Ato siya i-divide sa average speed of 40 feet per hour. So that will be 73.5 hours. Then for a 45-minute effective hour, the time will be 98 hours. So again, 73.5 times 60 minutes over 45 minutes na kanang time efficiency. Then to round it off sa full 8 hours day, that will be 104 hours. So now let's estimate the cost. So sa trenching machine, since ladder type atong gi-use, iyahang rate guno is 87.50 per hour. So 87.50 times 104 is equals to 9,100. Sa machine operator, 21.67 per hour times 104 hours is equal to 2,253.68. Then the pickup truck, natay $12 per hour times 104 hours, we have 1,248. Then laborer, 104 times 15.56 per hour, we have 1,618.24. Then sa foreman, 25 per hour iyahang rate times 104, then naatay 2,600. Then transporting machine to and from job, naatay gihatag na $1,500. So to add, the total cost will be 18,319.92. So we were also asked again to compute or to estimate the cost for linear foot. So the total cost divided by the kanang project, which is 2,940 feet, is equals to 6.23 per feet. So that will be our answer. Now to discuss the excavating with drag lines, we have Miss Josca Faye Kapalaran once again.
So next we have excavating with drag lines. So drag lines are used for excavating earth, for drainage channels, and building levels where water is present. So mo dyan siyang main nga use of drag lines. So the size of the drag line is indicated by the size of the bucket and usually expressed in cubic yards. So if material is difficult to excavate, so the use of smaller bucket will reduce the digging resistance, which may permit an increase in production rate. And these drag lines will produce its greatest output if the job is planned to permit excavation at the optimum depth of cut where possible. So to know the kanayang optimum depth, so we have this table. So this table sa so makita diha ang class of material and the size of bucket and cubic yards. So the upper number mo na indicate kanang duha man na siya ka row of numbers sa iyahang mga coefficients. So the upper is the optimum depth, which is expressed in feet, and the lower number kay mo na siya mga ideal output sa drag lines. So next is table 7.9. So kaning table 7.9 shows the effect of depth of cut and angle of swing on output of drag lines. So ang drag lines have cycle times. So kaning cycle time of dragline is composed of elements like scooping, nya muswing na sagbalik, then dumping, then swinging back. So ma-affected man na siya sa kanang angle of swing and the optimum depth of percentage of optimum depth. So i-multiply na siya og coefficients. So mo na siya ang coefficients if imong i-align ang angle of swing sa iyang percentage of optimum depth. So next. So next is a sample problem para ma-use itong tables. So to estimate the total cost and cost per cubic yard for excavating a drainage ditch 10 feet wide at the bottom, 36 feet wide at the top, and 12 feet and 15,110 feet long in good common earth. So the excavated earth can be cast on one or both sides of the ditch. So use a 1.5 cubic yards drag line and an average angle of swing of 120 degrees. It will require 2 days to set up and remove the drag line. So 2 laborers will assist the excavating operation, which will be supervised by a foreman. So assume the drag line will operate an average of 45 minutes per hour. So next, so let's solve this problem. So ato sa siyang i-illustrate para ma-imagine sa ninyo ang sayahang porma. So it is a trapezoidal nga shape. Na mo na siyang yung mga measures in length, base, and height. So to get its volume, so first kung ano to yung quantity of material. So volume is just the area of the trapezoid multiplied by its length. So we have 1/2 times the base, 10 plus 36 times its depth, which is 12, and the length of 15,110 feet. So the volume of earth is equivalent to 4,170,360 cubic feet. So i-convert na nato siya into cubic yards. I-divide lang siya og multiply og 1 cubic yard per 27 cubic feet, which is equivalent to 154,458 cubic yards measure. So next is kuha na to yung production rate. So to get that, we will use the table 7.8 para makuha ang iyang ideal output and iyang optimum depth. So makita man diha ang given was good common earth and the bucket size is 1.5. So if imo na siya i-trace and i-align, so we have 9.0 feet of optimum depth and 190 ideal output in cubic yards per hour. So next. So from table 7.8 and 7.9 na siya. Yes. Ay 7.8 rather. So mono to siya ang 190 cubic yard per hour and 9 feet ang iyang optimum depth. So para makuha yung percent of optimum, imo rang i-divide ang iyang depth sa iyang optimum depth of cut. So given man to ang 12 feet, so i-divide lang nato og 9. So na kay 1.33 or 133% of optimum. Next. So next is that we'll make use of the table 7.9 to get the depth swing factor or kaning siyang effect sa among depth and the angle of swing. So we have 133 man, so it is between 120 and 140 and an angle of 120 degrees. So natay 0.90 to 0.88, so between that. So next please. So using interpolation method, so makuha nimo ang iyang depth swing adjustment factor, which is 0.89. So to get its 60-minute hour production rate, imo siyang i-multiply ang iyang depth swing adjustment factor sa iyang ideal output, which is 0.89 multiplied by 190. So we can get 169.1 cubic yards per hour. And since ang iyang drag line is assumed to have can operate an average of 45 minutes per hour, so kuha na to yung 45-minute hour production rate, which is imurang i-multiply 169.1 multiplied by 45 minutes times 1 hour is equivalent to 60 minutes man per 1 hour. So we can get the 45-minute hour production rate of 126.8. So next, kay ang iyang time. So to get the time required to excavate the earth, so na naman tayo volume of earth in cubic yards and iyahang 45-minute hour production rate. So imo siyang i-divide of 154,458 divided by 126.8, which is 1,218 hour. Next is let us estimate its cost. So we have the cost during dragline operation, cost to set up and remove dragline, and cost to move dragline to and from the job. So cost during dragline operation, kay we have a dragline, multiply nimo yung R sa yung rate. Then we have machine operator said R times yung rate as well as the laborers. And we have 2 laborers sa kaninga operation, which is given. And then we have 1 foreman naman said, so iharang R multiplied by yung rate. So mo na siya, i-multiply nimo, we can get these values. Then for cost to set up and remove dragline, we have 2 days man ang iyang operation to get this excavation done. So 2 days, we have 8 hours each, so 16 hours. So multiplied by yung rate, so operator, we have 16 times 21.67. For laborers, we have 16 times 15.56. And we have 2 laborers, so that's $497.92. So for foreman, we have 1 foreman, then 2 days operation of 16 hour, and then a $25 per hour na rate, we have $400. Lastly, we have the cost to move dragline to and from the job, which is $2,500. So summing this all up, we can get the total direct cost sa ato ang operation. And then we are to get the cost per cubic yard sa excavation. So to get the cost per cubic yard, morang i-divide ang total direct cost sa volume of earth. So we have $205,299.28 divided by the cubic yards of 154,458. So we can get $1.33 per cubic yards. So next is the handling material with clamshell.
So next is the handling material with a clamshell. It is used primarily for handling loose materials such as loam, sand, gravel, and crushed stone. It is also suited for lifting materials, but not effective in loosening solid earth. The size of the clamshell is indicated by the size of the bucket, usually expressed in cubic yards. So we have example here. If the material must be discharged into a hopper, the time required to spot the bucket over the hopper and to discharge the load will be much greater than when the material is discharged freely into a large stockpile. So we have a picture here. It's a clamshell bucket. Ano si Cormano? So next is the excavating with hydraulic excavators. Usually, there are two types of hydraulic excavators. So depende sa type sa iyang pag-out, no, or digging action. So the first one is the front shovels. Uh, it is a hydraulic excavators that their digging action in an upward direction. So muna yung naong, no, so pasaka. So the other one is the backhoe. Mostly common kayo sa mga provinces, unlike sa front shovels. Backhoe is it is hydraulic excavators that have their digging action in a downward direction. So let's move on the front shovels, no. Uh, it's a maneuver on tracks. It is similar to bulldozers, mostly used in pit excavations of rock quarries. Excavating machines that can handle all classes of earth without prior loosening. But in excavating solid rock, it is necessary to loosen the rock first. So, di siya kakuan ng mga dagko nga bato. So, usually, by drilling holes and discharging explosive in them, so kailangan sa bukago sa daan. The size of a shovel is designated by the size of the bucket, expressed in cubic yards, loose measures. A bucket, no, can be rated as rack capacity or heap capacity. When you say rack capacity, is the volume in the bucket when it is filled even with but not above the sides. And when you say heap capacity, is the volume that a bucket will hold when the earth is piled above the sides. Depend on the depth of earth above the sides and base area of the bucket. So we have a table 7.11 provides fill factors of shovels. Percent of heap capacity usually no nakadepende siya sa unsa siya nga material. So makita naman sa table, no. Next is we have a four elements in the production process cycle of a shovel. We have load bucket, swing with load, dumping load, and return swing. Table 7.12 provides the range of element times for shovels with bucket sizes ranging from 3 to 5 cubic yards. So, load bucket range siya sa time na 7 to 9 seconds. Swing loaded, 46 seconds. Dump load, 2 to 4 seconds. And this one is swing empty, 4 to 5 seconds. So, the production of a shovel should be expressed in cubic yards per hour based on a bank measure volume. To obtain the bank measure volume of a bucket, the average loss daw of the volume should be divided by 1 plus the swell or the swell, no, the increase in volume compared sa initial volume. So over 100. So we have example here. If a 2 cubic yard bucket or the loss measure, no, is used to excavate the material whose swell is 25%, then the average loss volume can be calculated as 2 cubic yard over 1 plus 0.25, which is equals to 1.6 cubic yard bank measure. So if the shovel daw can make 2.5 cycles per minute, the output will be 2.5 cycles per minute times natin sa 1.6 cubic yard per cycle, which is equals to 4 cubic yard per minute. So in hour, so the bank measure times na to 60, which is equivalent to 240 cubic yard per hour.
Next, we will discuss hauling excavated materials. So, trucks are used to haul the material excavated by shovels. The capacity of the hauling unit can be expressed in tons or cubic yards. The capacity can be expressed as a struck or heap. So, na-discuss ni Joey kanina nga, the struck capacity is the volume that a unit will hold when it is filled even with but not above the sides. This volume depends on the length, width, and depth of the unit, while on the other hand, the heap capacity is the volume that a unit will hold when the earth is piled above the sides. So in the picture, we have the whole truck, and in the other picture, we have the sample sa struck and heap. So since shovel production rates are normally calculated in bank measure, it is desirable to express the loose volume of hauling trucks in bank measure. Na-discuss ni ganihan ni kapalaran, equation can be used for converting the loose measure to bank measure. So, for example, natay 15 cubic yard truck is hauling ordinary earth that has a swell of 25%. So, the bank measure will be 15 cubic yard all over the quantity of 1 plus 0.25 mo ni siyang katong percent sa swell. Mo na ato ang bank measure kay 12 cubic yard. So the size of the hauling unit should be balanced against the bucket capacity of the shovel. For best result, considering output and economy, the capacity of hauling unit should be 4 to 6 times the bucket capacity. So next slide, please. The volume that a truck can haul in a given time depends on the volume per load and the number of trips it can make in that time. The number of trips depends on the distance, speed, time at loading, time at the dump, and the time required for servicing. So higher travel speeds are possible on good open highways than on streets with heavy traffic. For example, top speeds in excess of 65 miles per hour may be possible on some paved highways mga mingaw nga kasada, whereas speeds on crowded city streets may be not more than 10 to 15 miles per hour. Delays can also occur at loading, dumping, and servicing trucks. Therefore, the actual operating time may be only 45 or 50 minutes per hour. An appropriate multiplier should be applied in determining the number of trips per unit of time. So, let's have an example. Assume the shovel and job conditions given in example 7.6 kato ganiha apply to a project that requires excavation and hauling of 58,640 cubic yard bank measure of common earth. Production rate of the shovel was calculated as 307 cubic yard per hour bank measure. The earth will be hauled 4 miles by 20 cubic yard. Loose measure. Trucks at an average speed of 30 miles per hour. The expected time at the dump is 4 minutes. So the truck time waiting at the shovel to move into loading position will have an average 3 minutes. Assume a 45-minute hour and calculate the total cost of and cost per cubic yard based on using sufficient trucks to balance the production rate of the shovel. So next slide for the solution. So first we need to have our quantity of work. So given tani ang kaning 58,640 cubic yard and which is in bank measure na, and then we have a 20 cubic yard nga masud na to sa haul truck. Nya ang kanang siyang 20 kay loose measure pa na siya, so ato na siyang i-transfer to bank measure. So mo ng 20 cubic yard over the quantity of 1 plus 0.25, we will have 16 cubic yard. So after sa quantity of work, mag-estimate na ta sa time, production rate, cost. So sa there is ito sa cyclic time of trucks, di ba? So sa loading truck na atay 16 cubic yard or 307 cubic yard per hour. Given man 300 cubic yard per hour. So muna ang ato ang truck kay makakuan mag 16 cubic yard, so ato nang i-divide mahimong siyang 0.05 R. Yeah. We have traveling 8 miles per 30 miles per hour. So ang kaning 8 mile kay di ba naman toy kuan natoy 4 miles. So i-times 2 to siya kay back and forth man, so mo ng 8 miles. Then i-divide sa katong speed sa truck which is 30 miles per hour. So we have 0.26 R. And dumping time which is given 4 minutes daw niya atong convert to R, we have 0.07 R. And waiting to load, so we have a given data nga 3 minutes, so to convert natay 0.05 R niya. Ato nang i-sum up, so total cyclic time, we have 0.43 hour per trip. So, arita sa production rate of trucks. So, number of trips per hour is 1 trip per 0.43 hour. So, mahimo na ni siyang 2.3 trips trips per hour. So, number of trips per 45-minute hour, kay kaning 45-minute hour, nag-assume man ta dito sa problem. So, munang 2.3 hour times 45 over 60. So, we have 1.7 trips per hour. So, volume hauled per trip. So, 1.7 trips per hour times 16 cubic yard per trip. So, we have 27.2 cubic yard per hour. So, muna siya sa atong production rate of trucks. Next, kay we'll calculate the time. So, number of trucks required ay 307 cubic yard per hour over 27.2 cubic per hour. So, we will need 11.3 trucks, which is round up, kaya di man pwede 11.3. So, 12. Therefore, there will be more trucks than required. The shovel at 307 cubic yard per hour will govern excavation product rate. So, naman tayo gihatag ato nga cubic yard. So, para makuha ang time, kay, diba, ang katong given 58,640 cubic yard over kanatong nakuha nga kanang time required nga, which is 307 cubic yard per hour. Okay, we need at least 191 hour muna siya itong time nga magkuan work. So, ari na ta sa cost. So, equipment, excavating, and hauling. So, sa shovel, kuan, ang pag-shovel daw sa katong excavate na itong area kay naay ka ng rate nga 135 per hour. So, times na nato sa pila ka hours ang work. So, 191 times 135 nga rate, kakuha tag 25,000 kapin niya. Sa truck, 191 times 12 man ka trucks niya. Ang rate ana nga gihatag kay 55 per hour. So, muna siya ang atuang gasto sa trucks. So, labor, excavating, and hauling the earth. So, shovel operator, kay natay 21.6 nga kanang rate. Sa truck drivers, 2 sikabok nga drivers niya ang rate kay 18.17 niya. Sa laborers, kay naiduha ka laborers, then ang rate which is 15.56 per hour. Then sa foreman, which is 25 per hour. So, we will get these values. Yeah, dito sa labor setting up and dismantling kay, diba, i-set up na to ang mga equipment and all. So, sa shovel operator, kay 2 days man na kay sa katong 1 day sa katong padong sa area niya, 2 day pabalik. So, muna 2 days. So, muna 8 hours, ang working hours man niya, times 2, so 16. Yeah, natay right there nga 21.67 sa shovel operator. Na sa laborers nga 15.56 per hour. Duha man kabuk ang laborers. Nya sa foreman kay 25. Nya mo na makuha ni natong mga values. And then natay transporting shovel to and from job nga kanang expense. Nya mo na i-add na nato. Nya we have a grand total of 212,443.17 dollars. Yeah. To convert it to cost per unit yard, so mo na ang grand total cost kay divide na to sa kanang cubic yard, which is the 58,640. So makakuha tag 3.62 cubic yard ang kuan cost. So that's it for.
So next, we have the backhoe. So Backhoe is a type of excavating equipment or digger consisting of a digging bucket on the end of a two-part articulated arm. So as you can see in the picture, sa na siya. Kailan naman gulo tag backhoe. So they are used to excavate below the natural surface such as trenches, basements, and general excavation that requires precise control of depths. So the production rate of backhoes depends on the bucket payload and its average cycle time. So next. So in the table 7.14, it represents the cycle time for backhoes under average conditions. The cycle time will depend on the particular job conditions such as difficulty sa paglusing sa soil, the angle of swing, and the size of the truck that the backhoe must load, and of course, the skill of the operator. In the table 7.15, it represents values of bucket fill factors for backhoes, and the fill factor of bucket depends on the type of soil to be excavated. Example, sand or gravel ba siya ang type sa soil nga excavate or hard or tough clay. And then the table 7.16 represents the probable output of backhoes. So next, we have a sample problem. So estimate the probable output of a 2 cubic yard backhoe for excavation of hard tough clay. Assume a swell of 30% and a 45-minute hour for the backhoe. So first, we will calculate the cycle time. So given man nga 2 2 cubic yard ang bucket payload, so maka-identify na ta sa mga factors from table 7.14. So load bucket, which is 6 seconds, swing loaded 3 seconds, dump bucket 3 seconds, return swing 4 seconds, and a total of 10 seconds per cycle. And we will convert it into cycles per minute. So ang answer would be 3.75 cycles per minute. And for the production rate, first we will identify the bucket fill factor since given man nga hard tough clay, so our fill factor would be 85%, and then average bucket payload, so cycle time I mean bucket payload times bucket fill factor is equal to 1.7 cubic yard. And then for the production rate, cycle time times the average bucket payload would be 6.4 cubic yard per minute. And then to get the 45-minute R nga loose measure, so 6.4 cubic yard per minute times 45 minute per hour is equal to 288 cubic yard per hour loose measure. And to get the bank measure, so katong formula nga volume of loose measure divided by 1 plus percentage of swell over 100. So we will be getting 222 cubic yard per hour for the bank measure. So next is excavating and hauling earth with scrapers. So scrapers are heavy equipment machines designed for the efficient removal and transportation of large quantities of earth, soil, or other materials. So daghan gamit ang scrapers, for example, in preparing the site. So before construction begins, scrapers are used to clear and level the ground. They remove topsoil, rocks to create a smooth and even surface. And also, gamit sad siya for material transportation. They are because scrapers are capable of loading, hauling, and depositing materials like dirt, gravel, or sand across construction sites. And for the classification of scrapers, we have push-loaded scraper. So the push-loaded scraper uses a crawler tractor to push the scraper to assist the loading. Next, push-pull scraper. A push-pull scraper allows two scrapers to assist one another during loading by hooking them together, as you can see in the picture. And then the third one is the self-loading scraper. Is sometimes an elevating scraper which is completely self-contained loading. Next is the production rate of scraper. So the production rate of scraper will equal the number of trips per hour multiplied by the net volume per trip. So the number of trips per hour can be obtained from the cycle time, the time required to load the hole and return. And for the cost of excavating and holing earth with scrapers, can be determined by assuming that the equipment will be operated 1 hour for quantity and cost purposes. The cost per cubic yard can be calculated by dividing the hourly cost by the hourly production rate of the scraper. And then next is the haul distances for scrapers. So for short haul distances, the production rate of a scraper depends primarily on the fixed time of the scraper, the time to load, accelerate, decelerate, turn, and dump. And as for the length of the whole distance, increases, the production rate of a scraper will depend primarily on the travel time of the scraper or the time to haul and return. So, sample problem. Estimate the probable production rate for a scraper whose truck capacity is 14 cubic yard. Loose measure. The material will be common earth with a swell of 25%. An evaluation of the whole road shows an average haul distance of 860 feet and return haul of 940 feet. Based on the condition of the whole road, it is anticipated that haul speed is 9 mph loaded and 11 mph empty. From the manufacturer's information, the load time is zero point 0.8 minutes and the dump time is zero point 0.7 minutes. Assume zero point 0.5 minutes for turning acceleration and assume a 45-minute productive hour. So first, we will calculate the cycle time. So hall speed, so 9 mph times convert into feet per minute. So we'll be having 792. And then return speed, convert also, so 968 feet per minute. And then for the load time, given naman zero point 0.8 minutes, then whole is 1.08 minutes, and then dump time is zero point 0.7 minutes. And then for the return, 940 feet divided by 968 feet per minute, that would be 0.97 minutes. And then turn acceleration is equal to 0.50 minutes. For the total of cycle time, 4.05 minutes per trip. And for the production rate, number of trips per hour, we have one one trip is equal to one trip over 4.05 minutes times 45 minutes per hour. So that would be 11.1 trip per hour. And for the volume per hour, the times siya 14 cubic yard per trip para makuha na to ang 155.4 cubic yard per hour loose measure. And since given man nga naatay swell, percentage of swell, so ato siyang ang loose measure divided by 1.0 1 plus 0.25 mao nakakuha tag 124.3 cubic yard per hour for the bank measure. So next kay shaping and compacting earthwork. So shaping and compacting earthwork are fundamental processes in construction and civil engineering, particularly in preparing the ground for various structures like roads, buildings, dams, or landscaping. So, shaping involves altering the existing topography to achieve desired slopes, elevations, and contours. So, ato magamit ng equipments kay bulldozers, graders, and excavators for cutting, filling, and leveling the ground. So, for compaction, after shaping the land, compaction is crucial to increase the density of soil and other materials to enhance their bearing capacity and reduce settlement.
So next we have the drilling and blasting rock. So before rock can be excavated, it must be loosened and broken into pieces small enough to be handled by excavating equipment. The most common method of loosening is to drill holes into which explosives are placed and detonated. Holes can be drilled by one or more several types of drills such as jackhammers, wagon drills, drifters, churn drills, rotary drills, and etc. The selection of equipment is based on the size of job, type of rock, depth and size of holes required, production rate required, and topography at the site. So next slide, we have the jackhammers, drifters, and wagon drills. So jackhammers can be used for holes up to about 2 inches in diameter and 15 to 18 feet deep. For deeper holes, the production rates are low and the costs are high. So for the wagon drills, may be used for holes 2 to 4 inches in diameter with depths sometimes as great as 40 feet, although shallower depths are more desirable. And last, the drifters are used to drill approximately horizontal holes up to 4 inches in diameter in mining and tunneling operations. So jackhammers, wagon drills, and drifters are operated by compressed air, which actuates the hammer that produces the percussion that disintegrates the rock and blows it out of the holes. Replaceable bits are attached to the bottoms of the hollow drills. Steels are commonly used. So next slide. So next we have the churn drill and rotary drills. So a churn drill disintegrates the rocks by repeated blows from a heavy steel bit, which is suspended from a wire rope. Holes in excess of 12 inches in diameter can be drilled several hundred feet deep with this equipment. Water which is placed in a hole during the drilling operation will produce a slurry with the disintegrating rock. A baler is used to remove the slurry. So, moto siya ang churn drill. Rotary drills can be used to drill holes 3 to 8 inches or more in diameter to depths in excess of 100 feet. Drilling is accomplished by a bit which is attached to the lower end of the drill stamp. Either water or compressed air can be used to remove the rock cuttings. So next slide. So ANFO is frequently used as explosive, although several other types explosives are available. So we will only feature the dynamite. So um, A- ANFO stands for ammonium nitrate fuel oil, and it is widely used explosive mixture in various industries, including mining, construction, and quarrying. ANFO is known for its simplicity, cost effectiveness, and ease of handling. ANFO is primarily used as a blasting agent for rock fragmentation in mining, quarrying, and construction activities. It is commonly used in open pit mining and large scale excavation projects. So dynamite is available in sticks of varying size which are placed in the hole. The strength, which is specified as 40, 60, and etc. percent, indicates the concentration of explosive agent, which is nitroglycerin. The dynamite is usually exploded by a blasting cap, which is detonated by an electric current. At least one blasting cap is required for each hole. The charge in several holes can be shot at one at a time. The amount of ANFO required to loosen rock will vary from about 0.25 to more than 1 pound per cubic yard, depending on the type of rock, the spacing of holes, and the degree of breakage desired. So, next slide, please. So, here we will have the cost of operating a drill. So, diri mo ni siya ang replaceable bits sa mga drills. The item of cost in operating a jackhammer or a wagon drill will include equipment and labor. The equipment cost will include the drill steels, bits, air compressor, and hose. Since each of these items may have a different life, it should be priced separately. Next slide. So these are the examples of rates in drilling holes. So the rate of drilling rock will vary with several factors, including the type of hardness of the rock, type and size of drill use, depth of holes, spacing of holes, topography at the site, condition of the drilling equipment, etc. So let's have the example problem. Estimate the cost of drilling and blasting limestone rock. An analysis of the job indicate that 3 inches diameter hole will be drilled 14 feet deep at a spacing of 8 feet by 8 feet. Two medium-sized wagon drills will be used for the drilling at a rate of 24 feet per hour each. It is anticipated that 1 pound of ANFO will be required to loosen each cubic yard of rock. Base all quantities and costs on operating 1 hour. So we have here the job requirements. The diameter of holes are in 3 inches. Depth of holes are 14 feet. Effective depth of holes is 13 feet. And spacing of holes is 8 feet by 8 feet. So first we need to get the equipment and production rate. So two medium-sized wagon drills matong gihatag sa given, and estimated rate of drilling is 24 feet per hour. Total production rate, two drills man times 24, so we have 48 feet per hour. And then effective depth of hole drilled kay 48 feet per hour times atong effective depth over the depth. So 13 over 14 is equals to 14.6 feet per hour. Yeah, volume of rock produced ay 44.6 feet times 8 times 8. Then i-convert ni siya to cubic yard. Now, mao na 27 dira. So we will have 106 cubic yard per hour. So number of holes drilled per hour is 48 times over 14, and we will have 3.44 holes per hour. So, mo siya ang materials needed for drilling and blasting. So, ANFO required kay 1 pound per cubic yard of rock. Unit cost, given ni siya, so 1.75 per pound. And then cost of bits kay 24.1 each. And number of times sharpened kay 3, kay tahalon tong mga bits. Cost of sharpening will be 3.15 each time. And depth of hole before sharpening bit kay 36 feet. Yeah, drill steel consumed kay 1 over 15 pound per cubic yard of rock. So we will now estimate the hourly cost of drilling and blasting. So drill bit consumption and cost. So original cost of each bit is katong 24.10. Yeah, sharpening, i-sharp man na to siya katulong. So 3 times 3.15, we have 9.45. Yeah, i-add na to. We have 33.55. So number of uses per bit, katong original bit plus katong tulog kaya sharp ay ganang gitahalan. So we have 4 uses per bit. Total depth of hole drilled by 1 bit, 4 times 36 is equals to 144 per bit. So cost of bit per foot of hole is 33.55 per bit times 144 feet per bit is equals to 0.23 per feet. So next we will calculate na the hourly cost. So dito una sa materials. So cost of bits per hour, 48 hour per feet times 0.23 per feet is 11.04. Yes, a drill, okay, we have 106 cubic yard per hour times 1 over 15 pound per cubic yard is equals to 7.1. Yeah, at a rate of 1.82, we will have 12.8, 12.92. Sa ANFO, kantong dynamite natong gamiton kay 106 cubic yard per hour maninya. We need 1. So muna 106 yeah, times the rate which is 1.75, we'll have 185.50. Yeah. Sa electric taps and wires, 3.44 holes per hour at ang rate kay 1.45, we'll have 4.99. So the cost per hour for materials is 214.45 per hour. So next, the equipment na ta. Wagon drills. So 1 hour times 2 drills man. Yeah. Times ang rate ato niya. So nata 84.6. Then sa air compressor, 1 hour times the rate will have 34.50. Then hose and connections, 1 and 1/2 in diameter. So ang rate anak ay 1.12. Utility truck, 1 hour. Ang 1 hour kay 8.50 ang rate. So, mo na siya 8.50 niya. Ato na i-sum up. we'll have our cost per hour for equipment, and that is 128.72 per hour. So next, last guys, hourly cost of labor. So drill operators, 1 hour, yan. Duha man to kakuan, up wagon drill. So munang we need 2 operators. Yeah, nag-rate of 21.67, we'll have 43.34. Then sa laborers, 1 hour times 2 helpers, na rate of 15.56 per hour, we'll have 31.12. Detonator person, 1 hour at 18 rate. So we have 18. Yung helper, 1 hour times ang rate kay 15.56. And then sa foreman, 1 hour at 25 per hour. So we'll sum this up. So we have the cost per hour for labor, which is 136.02 per hour. Next slide. So summary of cost, ipang-ada tong tanan. So we'll have a grand total of $479.19 per hour. Yeah, to have it in cost per cubic yard, kay ang grand total atong i-divide sa katong total nga cubic yard nga atong i-work. So 479.19 over 106 kay $4.52 per cubic yard. So mao ni siya. And this is all for group 1. Thank you for listening.
Okay, group 1. Are you done with your presentation?
Yes, Miss Mato siyang last.
Okay, so thank you. Okay. So, na ba may klase 3 to 4? Do you have class 3 to 4?
Wala, ma'am.
Okay, so mag-extend lang tag 5 minutes for comments. Okay. So class, do you have any questions with the reporters about the earthworks and excavation? Okay. So if you have questions, you can ask the reporters. Okay. So for my comment, okay, teamwork is okay. You have distributed the topics for the 5 members. Okay, the time also is okay. The visual aid. Okay, so makarelate ra ang tanan sa inyong gaistoryahan because of your visual aid. Okay, for the delivery. Okay. Okay, for the content. Okay. So as what I'm informed before, no, na I'm expecting you to show in class your actual plan. Okay, so na you can show an example because our reporting is focuses on the detailed quantity takeoff. So, okay, so I'm giving you the chapters as your reference, no, para naamoy idea what is your coverage. Okay, so for group 1, no, so I know nga inyong gikuha tanan ang inyong presentation sa chapter, no, pati ang mga example. But what I'm expecting you nga to show in the class is you have to produce your own plan, or maybe you can borrow a sample of like residential building ba or any commercial building to show, or any excavation project to show the actual quantity takeoff. Okay, so next reporter, please mind na that what is my expectation ha, kay we will focus on the detailed quantity takeoff. Okay, so I I understand no na it's okay. So it's okay for group 1 na you got na inyong gikuha ang tanang content. So I'm expecting also every reporter to take all the theory and also the calculation. But please mind na I'm requiring you to have your own plan to show in the class, the actual plan na construction drawings jud siya ha, na for us to have a concrete example. Okay, so next is the concrete works. So concrete works, concrete structures will be reporting on Tuesday. So what I'm expecting you is you can produce a sample construction plan. So I'm not saying na the whole project. So maybe a part of the project. For example, you have your first floor plan or the second floor plan that you can show to class how you get the quantity of your concrete. Okay, so our um, our reference is for you to know your coverage and also to have an idea na the concrete structures is not only focusing concrete, so napa na siya other elements. So mao tong na reference dito ninyo makuha and dito ninyo i-show sa class na um, our topic is not only limited to this element. So napa na siya daghan. So like what group 1 did, no? So daghan kayong klase nga mga excavation equipment and unsay mga gamit sa excavation equipment. So na siya specific equipment. So multi-purpose. So okay, so a big clap for group 1. So thank you for the effort. Okay. So any question for group 1? Walang may question? Okay, I remember last time na inangutan na if their group can make a quiz for the class. So the group 1 na may gi-prepare na ini activity, wala ra? Okay,
Wala ra, miss.
okay, wala ra. Okay, so for concrete structures, they will be reporting on Tuesday. And then on Thursday, I will be having a quiz on the approximate cost and also for the cost of construction labor and equipment. So, kani atong quiz sa Thursday next week will be charged to your midterm since wala tay quiz sa midterm. We got only the midterm exam pero wala tay quiz. So this quiz will be charged to your midterm exam. Okay? So any question? Okay, walay question. Okay. Naalang ko i-correct sa akong presentation kanina, no? Kay wala ko nahimutang asa tugikan ang 95. Okay, so ako lang i-correct class ha para magsubay ta. Okay, so ang 95 di ay na production rate is gikan sa problem. So, here, a small tractor loader can be rented at a cost of 50 per hour with a load production rate of 95 cycle per hour. So, gikan day siya sa problem nganong naatay production rate sa loader nga 95 cycle per hour. So, based sa atong problem na kuan, kay based sa atong calculation, ang pinaka-wiser jud is mo use ra ka og 4 trucks rather than 5 trucks. Kung 5 trucks mo mahal na siya. Okay, so mara na nga akong correction class, no? Kay as I prepare the problem, I understand nga upat ra jud ang pinaka-wise, not 5. Okay, so gikan ra dito siya sa problem itself nga 95 cubic yard per hour ang production rate sa kuan sa loader. Okay, so maulang tong akong correction. Okay, so do you have any concern? Wala na? Okay, if wala na. Okay, so thank you Kapalaran, Santos, Lisaw, Inot, and kinsa to ang isa, si
Cavite, Miss.
Cavite. Yes, si Cavite. Okay, sorry Cavite. So okay, so this you have your individual grade and you also have the group grade. Okay, so thank you for the presentation. If no more question, you can leave the meeting and thank you guys.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank you.
Thank you, ma'am. Bye, ma'am.